Okay, so this is going to be the last lesson in the unit. Today we're going to be talking about trapezoids and their subcategory of isosceles trapezoids. So we're going to go ahead while we're up here, we're going to fill in both of these squares. Sorry, I keep saying squares. These are just blanks. Fill in both of these rectangles. This first one is a trapezoid. And the next one is an isosceles trapezoid. I want you to think for a second, where did we hear that term isosceles before? Okay, we should have heard that with triangles. We talked about isosceles triangles beginning of the year, beginning of the semester. And isosceles just means that two of the sides are the same. Well, isosceles trapezoids also have that property, that two of the sides are the same. We'll talk more about that in a little bit. But we do know that all trapezoids, whether they're isosceles or not, have in common that they have exactly one set of parallel sides. So by this point, we should have this entire section filled in. If you don't, go ahead and make sure that's filled in. Pause the video, copy it down. And if at any point you feel like I'm going too fast, you can do the same at any point. Pause the video, rewind it, slow it down, whatever you need to do. Once you've copied this, go ahead and flip to the page on trapezoids where we're going to finish out our notes. And like I said, trapezoids are quadrilaterals with exactly one pair of opposite sides parallel. And that pair of opposite sides that's parallel, both of those sides are called the bases. So the bases of our trapezoid. Those sides are parallel. And we're going to mark those down. That means that segment TR is parallel to segment PA. And if you recall, those arrows in the middle of the lines tell us that those segments are parallel. The other thing we know about trapezoids in general is that the other sides are called the legs. They're called the legs of your trapezoid. So that's segment TP and segment RA are the legs of the trapezoid. It's just some terminology that you're going to be needing to know. This is definitely one of those things you're going to want to remember. Which ones are the bases and which ones are the legs. The last thing we know about all trapezoids is that the consecutive interior angles are congruent. No, they're not. I said that wrong. Consecutive interior angles are supplementary. They are supplementary. And consecutive interior angles are not just any two angles that are next to each other. They are specifically these angles here and these angles here. We get those from the fact, and you don't need to write this down, but I do want to show y'all. We get those from the fact that if these lines are parallel, then I have two parallel lines cut by a transversal, which means from all the way back in Unit 3, we have angles here and here, which are called consecutive interior angles. And we have angles here and here that are consecutive interior, those angles here and here. But that's a lot to write down every single time. So I'm going to give you all a little bit easier definition of consecutive interior, just so we don't have to draw those arrows every single time. Consecutive interior angles are angles that share a leg. So, for instance, the leg TP has angles T and P on it, so those angles are supplementary. Same thing with R and A. R and A are supplementary angles. So we're going to say consecutive interior angles are angles that share a leg. And that means we've got angles T and P. equaling 180. And we've got angles R and A equaling 180. So both of these are supplementary. That's really all we know about all trapezoids. What's more important and what's more practical and useful is isosceles trapezoids, which are trapezoids with two sets of congruent, or with two congruent sides. Those sides that are congruent are the legs. So in an isosceles trapezoid, the legs are the two parts that are congruent. So we're going to draw that on our diagram, that AD and BC are congruent segments, because those are the legs. Those are the sides that are not parallel. So AD and BC are congruent. Now, not only are the legs congruent, but the base angles are congruent as well. So angle A is congruent to, wait, hold on, we don't know what base angles are. Now, base angles, as the name might suggest, are simply angles that share a base. So we talked about consecutive interior angles, or angles that share a leg. Base angles are angles that share a base. Base angles are angles that share a base. So the bases AB and DC, we know that, no, AB and DC, that's what I said. AB and DC. A and B share a base, AB, so that means angle A is congruent to angle B. And D and C are congruent because they share a base. They share DC. So those are congruent as well. And we're going to mark these on our diagram so we don't forget about them. A and B are congruent, and D and C are congruent. Now the very last, excuse me, let me get some water. The very last thing that we know about the isosceles trapezoid is that the diagonals are congruent. The diagonals are congruent. So we're going to draw our diagonals in just like we did with the other shape. And we know those diagonals are congruent. And on these diagonals, I don't want you to put in a point in the middle. That point, while it's technically there, it's not really important and we don't use it for anything. And I don't want you to confuse it with any of the other shapes that the point does bisect. The point in the middle, this one here, where the two lines intersect, does not bisect the diagonals. The only thing I know about the diagonals of my trapezoid is that they're congruent. So AC is congruent to BD. That's it. So we're going to mark that on our picture, but that's all we're going to do. Now, the last thing we're going to talk about in this unit is the trapezoid midsegment. And you might have heard of midsegments before when we did triangles. We did triangle midsegments. And the midsegment of trapezoid is a very similar idea. It's kind of the middle line halfway between each base. And the reason it's called a midsegment is because it is the segment composed of the two midpoints of either leg. So E is the midpoint of leg AD, F is the midpoint of leg BC, and so EF is the segment between those lines, between those two midpoints, so it's called the midsegment. And there is a formula that we use to describe the midsegment. We know that the midsegment of a trapezoid equals half the sum of the bases. It equals half the sum of the bases. So basically, if we know EF is the mid-segment, then that's equal to half of AB plus DC. Another way to say this more generally is that the mid-segment, whatever the mid-segment is equal to half of the first base plus the second base. There's two bases. We're going to add those together, set them equal to the mid-segment after you cut them in half. So what we're going to do, we're going to look at our diagram here, and we're going to say which one is the mid-segment. The mid-segment's always the halfway point. It's the one in the middle. So our mid-segment is P, in this case, which is equal to half of the base plus the other base. The first base is that one here, P plus 17, plus the second base, 2P minus 76. Close our parentheses off. And the first thing that I like to do is I like to clean up the inside of the parentheses first. You don't have to do this first, but I like to do it first. It just makes a little more sense to me. So we're going to leave this alone. P equals 1/2. And then on the inside of the parentheses, we've got P, 2P, 17, and negative 76. We've got 4 parts. We're going to combine our P's, and that should give us 3P. And then what is the sum of 17 and negative 76? Okay. So you should have gotten negative 59, which is a little bit cleaner. It looks a lot easier to deal with now. Now the next step in the process, I would go ahead and try and get rid of this 1/2, because you don't want to multiply 1/2 by those two things, because those are both odd numbers. If I multiply 1/2 by 3, I'm going to get a decimal, and I really don't want to deal with that. So what I'm going to do instead is I'm going to cancel out the 1/2 by multiplying by 2. And if I multiply by 2 on this side, I have to multiply by 2 on this side. These two cancel, and then I'm just left with 3P minus 59 equaling 2P. From here, you should be able to solve the equation very easily. I'll give you all a second to do that. If you just pause the video, finish it out on your own, and then you can check yourself. Okay, so we should be taking away 3P from both sides. So we get negative P equals negative 59. Every time you have two negatives, where both values are negative, you can just drop the negative on both in this case. And that means positive P equals positive 59. So we found P, that's our mid-segment. If I wanted to, I could go ahead and find A, B, and DC. Go ahead and do that. I'm going to leave that to you. Just remember, anytime you see a trapezoid with a mid-segment, or basically a line going halfway down the middle, you're going to be using this equation.